This is Deepika from Triple E Department, and today my topic is DC generators. Introduction to DC generators. A DC generator converts mechanical energy into direct current and electrical energy through electromagnetic induction. It is a commonly used in applications requiring stable and controllable of the DC power sources. The understanding its working principle is essential for designing and maintaining electrical system in the DC generators. A DC generator converts into mechanical energy into electrical energy. It is requiring stable and controllable DC power sources and maintaining in the electrical system. Basic constructions of a DC generators. The main components include the armature field poles, computers, brushes and yoke in the DC generators. The armature consists of winding coils where voltage is induced in the DC generators. The field poles produce a magnetic field that interacts with the armature in the DC generators of a armature in the voltage and induced. Working principle of a DC generators. The working principle when the armature conductors rotates within a magnetic field and electromotive force EMF is induced. In the DC generators, the computer reverses the directions of computers in the armature winding to produce unidirectional current in the principle of a DC generators. The continuous rotations of a armature results in a steady of a DC output in the principle of a DC generators to produce unidirectional current in the generators. And next point is types of DC generators. Separately excited generators have their field winding energies from an external sources in the DC generators. Self-excited generators are used their own output to encourage energies the field winding. The main types include series, shunt, compounds, generators, each suited in the different applications in the DC generators or output to energies the field winding in the energies from an external sources in the DC generators. And next point is the voltage regulations in a DC generators. The voltage regulations refers to maintaining a constant output voltage despite load variation. It depends on the extraction current and speed of the armature in the voltage of a DC generators. The proper designs and control mechanisms are used to achieve desired regulation levels in the regulations of a voltage in the DC generators. And next point is advantages and disadvantages of DC generators. Now we'll see the advantages of a DC generators. They provide a smooth, controllable DC output suitable for many industrial applications in the DC generators. And next point is they are capable of supplying high starting torque for the motors. And next point is the design allows for easy voltage and regulation adjustable output in the DC generators. These are the advantages of DC generators. And next we'll see the disadvantages of DC generators. They require maintenance of brushes and commuters which can lead to wear and tear. They are less efficient compared to AC generators due to brush contact and the losses. Their size and complexity make less suitable for modern large-scale power generation, and these are the disadvantages of DC generators. And now, applications of DC generators used in laboratory charging, electroplating and welding application. In the DC generators, they serve as power source for DC motors in industrial machinery. And the last point is used in laboratories and testing setups requires tables of DC apply. And next, maintenance and troubleshooting. Regulation inspections of brushes and computers ensures efficient operation. Cleaning the lubricant of moving parts prevent the mechanical failures. And the conclusion, DC generators are virtual components of various electrical and industrial systems advanced in Technology continue to improve their efficiency and application scope. Thank you.